The corresponding angle postulate states that if two parallel lines are intersected by a transversal, then the corresponding angles are congruent. So here we have two parallel lines, and we've got our transversal. And so our transversal is this line right here. Okay, and if we have angles, and we have angles that are formed, we've got angles 1 and 2 and 3 and 4 and 5, 6, 7, and 8. So we've got 8 different angles that are formed, and we know that the corresponding angles based on the corresponding angle postulate would be congruent to each other. Okay, so when we're talking about corresponding angles, we're talking about in relation to the transversal and the parallel line. So angle 1 here is to the left of the transversal and above our parallel line. And so angle 1 is in a corresponding location with angle 5. So these two angles would be congruent to each other because they're both to the left of our transversal and above our parallel line. We can see that angle 2 is to the right of our transversal and above the parallel line, and angle 6 is also in that same corresponding location. So these two angles would be corresponding angles. Angle 3 is to the left of our transversal, below our parallel line, and that's in the same location as angle 7, to the left of our transversal and below the parallel line. And then we've got angle 4 is to the right of our transversal and below the parallel line. And here we've got angle 8 in that same corresponding location. Okay, so we can say that angle 1 is congruent to angle 5. And we know that because they're in corresponding locations. And this postulate, which does not have to be proven, simply states that corresponding angles are congruent. So angle 1 is congruent to angle 5. And angle 2 is congruent to angle 6. And angle 3 is congruent to angle 7. And then we've got angle 4 is congruent to angle 8. Okay, so these are the corresponding angles, and we know corresponding angles are congruent to each other. So we can go ahead and use that information in our proofs because we do not have to prove anything. So if we look at our next theorem, the next theorem is the alternate interior angle theorem. And it says that if two lines are intersected by a transversal, then the alternate interior angles are congruent. Okay, so our alternate interior angles here are going to be, and we're actually trying to prove this, sorry about this. This should be a 3. Our alternate interior angles here are, we're trying to prove angle 3 and angle 6 is congruent. Okay, so we're trying to prove that this angle here is congruent to this angle here. We're told that line W is parallel to line X and that Z is a transversal. Okay, so I can say that line W is parallel to line X, and that's given, and line Z is a transversal, and that's given. But honestly, you don't have to write that second line there. You can, but it's not really going to affect our proof. Okay, so what we can use are any of the things that we've already proven. Okay, so we can start by saying that angle 2 corresponds to angle 6, right? They're in corresponding locations. So we know that angle 2 is congruent to angle 6. And this is because they're in corresponding locations. So corresponding angles, oh goodness. Okay, so by the corresponding angles postulate, we know that angle 2 is congruent to angle 6 because they're in corresponding locations. Okay, so we know that angle 2 is congruent to angle 6 that's what we've proven, or that's where we are so far in our proof. And what do we know about angle 2 and angle 3? Well, angle 2 and angle 3 are vertical angles. So we know by the vertical angle theorem that those two angles are also congruent. So we can say that angle 2 is congruent to angle 3, and that's by the vertical angle theorem. Okay, and now we have a commonality here. We've got the measure of angle 2 is congruent to the measure of angle 6, and the measure of angle 2 is congruent to the measure of angle 3. So what property allows us to say that the measure of angle 3 is congruent to the measure of angle 6? Actually, we're not saying the measure. We're saying that angle 3 is congruent to angle 6. Okay, and we can say that by the transitive property. Okay, so if I've been saying the measures, I apologize, guys. We're strictly talking about congruence and angles being congruent, so we're not talking about the measures being equal here. But we've got that line W is parallel to line X, and then Z is a transversal. And so because of that information, we can see that angle 2 and angle 6 are corresponding angles, which means that they're congruent to each other. And then we can look and say that angle 2 and angle 3 are vertical angles, so they're congruent to each other. And then we could simply state that the measure, or that angle 3 is congruent to angle 6 by the transitive property. And that is where this proof ends.